Hello, I'm Dave Fields with the University of Washington. I'm a facilities manager here, and one of my responsibilities is to lead a group called the Conservation Project Development Team. And our group gets together on a regular basis, and we brainstorm and develop and then implement water conservation and energy conservation projects on campus. Over nearly the last 10 years, we've managed to reduce our water consumption by nearly 40%. That's roughly 800,000 gallons of water saved per day. Some of the projects that we've done here on campus that have been the most effective have been, number one, to look at maintenance issues that we have on campus. Here's 5 different areas of water consumption that we took a look at, and that was faulty equipment, then sterilizers, our domestic usage, which would include toilets, urinals. Then we looked at our cooling processes, then leaks and other miscellaneous areas. I've worked closely with Roger Van Gelder, who's a consultant for Seattle Public Utilities, and my colleague John Layden, who will take you on a tour to show you some of the projects that we have done.
Good afternoon. I'm John Layden, project coordinator at the University of Washington. I'm here with Dave Fields and Roger Van Gelder to look at some of the projects we've installed through the years. This was one of our introductory efforts into water conservation. This is the McMahon Hall dry cooler. At the time it was installed in 2002, we were consuming a little over 5,000 hundreds of cubic feet per year. When the dry cooler was installed, it eliminated all of the domestic water consumption, bringing it down to zero. So our savings amounted to a little over $38,000 per year. The process is one similar to an automobile radiator, where water is circulated through the dry cooler back to the refrigeration equipment. As I recall, there's 6 individual refrigeration units for the walk-in freezers in the kitchen area. We're now in the refrigeration room in the McMahon Hall kitchen, and these are the 2 pipes leading out to the dry cooler. They extend upwards through a heat exchanger, and then the water coming out of the heat exchanger is circulated through the refrigeration units. The reason for the heat exchanger unit is simply to isolate between the 2 systems. The system going out to the dry cooler has antifreeze, so it's protected the year round. The system cooling the refrigeration equipment, of course, is just recirculated water. And it's kind of a piping menagerie, but we have 1, 2, 3, 4, 5, 6 units for the various walk-in meat coolers and produce coolers. This again was one of our first installations accomplished in 2002. Originally we had 2 water ring type vacuum producers. With their short cycling and water consumption equated to about 7,500 gallons per day. Well, the units that you're seeing are air-to-air vacuum producers. They use no water whatsoever for cooling. So we went from 7,500 gallons per day to 0 gallons per day. We're estimating an annual savings of $26,000 per year. Again, this was at 2002 dollars with a payback period of 0.6 of a year. So although challenging, it was an excellent installation product and it served well through the years. One of our significant projects was putting in what is called a water miser that reduces the flow from sterilizers. What we're looking at is the backside of a sterilizer, which is used to sterilize some of the medical and research instruments. The water miser is the cylindrical assembly. It has a sensor that measures 140 degrees, which is the highest temperature we're allowed to put down to the sewer. So the reservoir helps temper that, and then as the temperature rises, some water is added to cool it. They were running constantly somewhere between 1 and I think the highest was 2.7 gallons per minute, which is a continuous flow. We were able to reduce that practically down to 0 Anticipated savings was $207,000 a year in avoided water costs. At the time they were installed, we had a simple payback of 0.45 years, or just a little bit under half of a year. It was an excellent project. It was one of the first that we had rebate participation from Seattle Public Utilities. Good afternoon again. We're now looking at the Drumheller Fountain. Originally, this was built during the 1900s for the Seattle Yukon Exposition. The fountain includes the fountain that you see, and then also there's about a 10 to 12 foot wide moat that's underground surrounding the fountain. Prior to the relining of the fountain, we were losing about 80,000 gallons per day of water. During the retrofit, the moat was filled with concrete and sealed. Then there was a neoprene liner installed in the actual fountain itself, which cut the leakage rate down to zero. We are now in the intramural activities, or IMA men's shower room. This is one of 3 locations that we've retrofitted with low-flow shower heads. There are 2 locations in the men's shower room and another in the women's that involved about 120 shower heads. This was actually a student-initiated project that started out a couple of years ago. The students did a lot of research. I think this is the 3rd iteration of a shower head that we had tested. Originally, the flow rate on the shower head varied from 3 to 3.6 gallons per minute. These are rated at 1.6 gallons per minute. The reduction of 50% is an outstanding feature. We went through the campus and renovated something on the order of 1,700 toilets, from 3.5 gallon per flush to a 1.6 gallon per flush. Unfortunately, we got into that project before the 1.28 gallon per flush toilets became available. It was a good project, excellent savings at the time. Following that, we went into a renovation of urinals, where we reduced again from 3.5 gallons per flush to 1/2 gallon per flush. We are in the IMA shower room area. What we're looking at here are the retrofitted urinals. Originally, these were 3.5 gallon per flush. We originally replaced these with waterless urinals. Unfortunately, they didn't work out that well. They were plugging up at a frequency of about every 2 months or less. They were removed. What you're seeing is a 1/2 gallon per flush urinal. So with the indulgence of the IMA staff, we were able to change these out, provide a much better product, and one that should work well into the future. That, in a nutshell, kind of brings you up through the years from when we started our water conservation program to the present day.
So through our water conservation projects and through financial incentives and support from Seattle Public Utilities, we've managed to have a cumulative savings of around $19 million.